Hello everyone, I'm audible. I'm audible to you all.
Yes, you are audible. So you can file you can present after 5 minutes. Let it wait other participants.
Okay, sir.
हेलो एक्सेस दे दीजिए इस भाई को ओपन करने के लिए
नेट नहीं चल रहा।
हेलो आया इंडेक्स क्यों हो गया शेयर करो हेलो एक्सेस दे दो और पता है कितने ऑप्शन नहीं आ रहा था अब आ गया
So let's start our session. Firstly, I'm very thankful towards Mr. Anil Kumar Sharma sir, who give the opportunity to present as a speaker. And I'm also very thankful to all the participants who joined these sessions. I hope you already joined the previous session as rescue, nanotech, kitty cat. Now it is a 4th day of FDP. So we will be discussing about SETFOS, and at the next day with the same time 5 to 7, it upcoming schedule of the semiconductor characterization of the SET and rescue plus and nanotechnology plus software sessions are scheduled. So please don't forget to join it. If anybody who has not seen it my previous session, so please go to the YouTube channel of Impulse Technology and can see it. So we will be first go with a small presentation, then start live demonstration. Before start of my presentation, I want to introduce myself. I'm Sahil Verma, application engineer of the well-known company Impulse Technology. Impulse Technology provides cutting technology of the next generation nanoscale material and device, semiconductor device, TCAD and quantum technology, spin qubit, quantum dot semiconductor device simulation software for education, commercial and research and development sector in India. Company also have partnership with Nano Academics, which is Canada-based company that offer several software like Nanotechnology. It is used for device and material simulations. Another is Rescue software. It is used for material simulations, and QTCAD. It is used for cloud-based material simulation. One of the well-known Metra, which is used for material and research cloud-based simulation. And now we are going to discuss about Proximity, which developed SETFOS software. We have majorly focused about the SETFOS software in this session. Our company, Impulse Technology, provide many of the services like software distributor, training program, technical supports, and equipment. They also have a equipment micro stations like solar cell, thin film, FET, gas chamber, transistor. For the more detail of our company, you can check our websites impulsetechnology.com and also Fluximagy company. Company also have valuable customers like IIT Guwahati, IIT Madras, IIT Dhanbad. So number of customers are present in India. So you can check. I'm here to discuss about the SETFOS software which developed by Fluximagy company. It is a Switzerland-based company. They develop scientific tool that boost your research and development. It is a simulation software, upscaling for large area, measurement hardware for OLED, perovskite, solar cells, and OPV, and electrical properties. It outcome generally based computational physics, the Zurich University of Applied Science. In 2006, Dr. B. Hustler founded that Fluximagy as a spin-off company. Some scientific tool that boost research and development, it is a SETFOS simulation software for organic and perovskite solar cells. LIOS, it is a simulation software for upscaling to large area device and OLED and solar cell. They also used for calculate electrical losses in the large area networks. And another is POIS, which is electrical characterization of OLED and solar cell. It is used for transient photoluminescence and transient photocurrents. One is PHELOS, which is it is a angular luminescence spectrum meter to characterize the light emitting device. Simple word we can say angle dependent electroluminescence and photoluminescence spectrum measurements. One is LIGHTOS. It is a test platform for the stress, the degradation analysis of LED. It is an advanced LED stability lifetime measurement system. And next we will go with the LIGHTOS Lite. It is a platform to perform parallel JV and stability measurement of organic perovskite solar cell and perovskite solar tandem solar cell. If you want more information, you can check Fluximagy.company websites. It is a SETFOS semiconducting thin optic simulation software. As per name, you can understand about it work on the simulation software for optical and electrical modeling of semiconducting device. It used for designing LED solar cell based on organic semiconductor, perovskites, and quantum dots. Fitting and optimization algorithm also included. Fitting and optimization algorithm means if you can basic simulation, but SETFOS can optimize this simulation with better accuracy and better measurement systems. It uses for the operating systems that Windows 10, which have 64-bit versions, Linux 64-bit, and Mac OS 11 like that. Multi-threading ensure high-speed computation. SETFOS not limited for the one process. It at the single time number of process parallelly can occur with the high speed. It doesn't take more time. SETFOS uses variety of model to simulate optoelectronics, including generally every softwares work on the some of the models which follow some of the scientific criteria. But SETFOS that generally follow dipole emission models that predict light emission characteristics of OLED. And second is transfer matrix formalism that calculate photon flux across the solar cell. And third is drift division modules, model charge, transports, and recombination. Fourth is my scattering that optimize the concentration and refractive index of the particle that scatterings. I will be discuss about the perovskite solar cell majorly because if you go to the live demonstrations, then I consider one of the example for your better understandings that it will be a layer metal, hole extraction, perovskites, electron extraction, ITO, and glass. It is the process that given at here. So that similar layer you can apply at the SETFOS GUI, which can give the results. Perovskite solar cell, it is a type of photovoltaic device in which perovskite structure compound of lead halide materials, which like act harvesting active layer with other components. Perovskite solar cell majorly used because it have low cost production and give high efficiency. Perovskite material excellent light absorption, charge carrier mobilities, and lifetime resulting high device efficiency. So generally people prefer perovskite cells. They also possess many optoelectrical properties that benefit their usage in solar cell. So we can calculate all of the perovskite solar cell properties in the SETFOS software. I consider second example, it is an organic light emitting diode. It is a solid state device consisting of thin carbon-based semiconducting layer that emit light when electricity is applied by adjacent electrodes. OLED are used to create digital display in devices such as a television screen, computer monitors, and portable systems such as a smartphone and handheld game console. India working on the development of that field, so majorly uses SETFOS software for the major study. Two main families of the OLED, it is those based on small molecules, those employ polymers. In this diagram, we can see when we apply voltage across OLED, electron passes from the cathode and hole from the anode. They move toward the emissive layer. When exciton pair form, so leading current through device. When the charge of exciton path is combined, so they will emit light. So SETFOS majorly work on that field. So they follow same of the procedure in SETFOS GUI. There you applied all of the input. It is a geographical user interface of the SETFOS, which easily can be access to device structure, material parameter, working file simulation output. Multiple simulation can run in parallel, as I have already told. Result automatically fastly generated that can export at different file formats. This is fully compatible with Python. As in the example, you can see the number of layer is present. So in the SETFOS GUI, I give all of the layer as aluminum, spiro, perovskites, phenoxides, FTO, and surroundings. So you give the all of layer and different modules are given and you apply all of the inputs and get your desired result. In the live demonstration, I will explain each and every tool. SETFOS generally have 4 modules which can simulate. Each modules have a unique feature to calculate various characteristics with higher accuracy. As I'm going to discuss about here, absorption modules, that absorption of the sunlight spectrum by solar cells, and drift vision modules that calculate electrical behavior of the DC transient or AC signal of the OLED and solar cell. And the emission, calculate the emission of light from thin organic microcavities. And advanced optics module used to design OLED and solar cell with scattering properties to enhance in outcoupling of light. Basically means these modules, if you want to calculate absorption parameters, you can purchase absorption modules. And if you want to drift vision, you can use that modules. If you want to outcouple of these modules at absorption plus drift vision, like emission, if you outcoupling these modules, you can also use as per your choice. At the next slide, further we move, we can see at here result view of perovskite simulation SETFOS. As I have given in a geographical user interface all of the input and all of the parameters that they want and results we can see at here perovskite simulation in the SETFOS. As some of the diagram I am showing at here layer absorptions and transmitted. You can see at number of the diagrams when we will perform our tutorial, so I will show you. In that figure you can see additional information, electrical profiles, numerics, and optical integrated, passive optic properties, and spectral emission. Spectral, you can also see at here. So at the second example of the emission OLED, you can see emission structures which dependent at y-axis is the emission and x-axis as the wavelength and color diagram and emitted light as shown at here. So spectral emission you can also see at here, spectral optical profiles, emission properties, and exciton density as in come on the optical profiles, radiated or dipole density, you can see at here. I am performing at here optimization for the OLED emission, so I will also show you how we can fit and get accurate results. So I'll move on the next slides. We can see SETFOS had a different uses as design and optimization. We can also perform simple simulation, but if you want to optimize and with greater accuracy, you can also optimize their inputs. SETFOS can use to design and optimize the performance of solar cell as LED and photodetectors. SETFOS supports impedance analysis and transient analysis. It advanced research and development supports model for mobile ionic charge. Generally, it means many of the researchers use the SETFOS model so they can validate their results. And SETFOS give high accuracy results. Simulation. SETFOS simulate variety of properties, including light emission, absorption, scattering, charge transport, short circuit currents, open circuit voltage, field factors. SETFOS support unlimited layer modeling for LED and solar cell and total absorption and each specific layer absorption. So SETFOS also include material property database. One of the major advantage, it is a graphical user interface. SETFOS have the simple GUI. At the simple GUI, you can see use all of the modules and all of the parameters you can given at the simple GUI. It is very easy to use. Now, people want how we can use SETFOS and why we use SETFOS, because Escape only one of the free and limited tools present, so many of the researchers and people use that tool. But I supported that if some tools it's free, they have also some limitations. So SETFOS generally it is a commercial software with high regular update and user support and training support. But Escape only will free as limited supports. Generally, SETFOS also has some of the features. There no limitation of layer, supports transient simulation as I already told. All optical properties can be calculated, support mobile ion cation and anion, support roughness and scattering particles, compute the clear sky spectrum for given geographical location and time, support parameter, shift and optimization. You can multiple parameter can be shift and optimized as we have told. Supports hopping model for interface as ion and cation are excited, so we can also calculate it at here through the interface. SETFOS can perform small signal analysis as SETFOS is commercial software that regular updates are present. As compared of the SETFOS, Escape only support for the 7 layer. It does not support transient analysis. It is not possible to calculate optical properties, does not support ion cations and anion. It also not support roughness and scattering. It does not support location and time. But in a SETFOS, you can give your time, location, and everything that you want. At the spectrum, they present at here. And one of the benefits, SETFOS can also consider your own input. If you want create your own data, you can give at here. Does not support shift and optimization in Escape only. Escape only does not support hopping model. It does not perform small signal analysis. Escape only one field free has limited support. SETFOS also has simulation software that optimize the design of LED, solar cell, and batteries, as we have known. But SETFOS also have major applications that people prefer to use. It is an organic, inorganic solar cell, perovskite tandem solar cell, heterojunction solar cell, dye-sensitized solar cell, organic photodetector, quantum dot solar cell, organic light emitting diode, perovskite LED, white LED, OLED also are possible. Tandem OLED, polymer LED blue, OLED, hydrosperscents. So SETFOS generally focus on that semiconductor material, so we can use SETFOS in semiconductor materials. Many of the customers of the SETFOS present in India, they generally as IIT Madras, IIT Guwahati, IIT Roorkee, Dhanbad, Bangalore, IIT Allahabad, Brahmpur University. So you can check number of the customer lists. They have also some of the customers you can see. SETFOS not only use it for your purpose, you can also use at the research. Many of the researchers prefer to use and they simulate their results and as you can see at here, SETFOS device simulation, that one of the researchers that perform their simulation at the Fermi layer of electron under reverse bias conditions at upton from distribution simulation with SETFOS device simulation tool. So multi-scale simulation of reverse bias breakdown in perovskite tandem solar cells. The research are also published. So it does not limit tools. Many of the people are uses their tool. And before, at the end of the presentation, as I will show you about the Fluximagy company. You can see it here, Fluximagy have many of the scientific tools that boost your research and development. As SETFOS, introduction, emission, absorption, distribution, advanced optics are given at here. LIOS, electrical module, thermal module, optics modules are also at given. So Fluximagy give all of the data at their software which they develop, so you can check by your own sites. As electrical and optical characterization of LED and solar cell are given. Fellows like generally have already told angular luminescence spectrometer to characterize light emitting device. Photoluminescence and the graph also at shown in here. Many of the applications are given at here: solar cell, OLED, photovoltaic, OLED tutorial, stability of the perovskite solar cell. You can check at here. Many of the researchers also publish. So every publications are given at here. As you can see, elimination of ion conductivity in perovskite solar cell. Triple junction perovskite silicon solar cell with power conversion efficiency. If you go below sites, you can see number of the researchers publish their data and their graph used by the SETFOS software. You can also check our channel, number of videos given at here in my YouTube channel or in our company YouTube channel, Impulse Technology. As electronic OLED simulations, light emitting device simulation of SETFOS software given at here. Introduction to quantum tech also given. More number of playlist present at here. So you can give brief discussion and also you can elaborate yourself to study. As the SETFOS tutorial top to bottom also given, and device studio, QTCAD, rescue softwares, and Leos, Nanotechnology software. You can study at here which you want, and you can also contact our team in Impulse Technology. You can also book our demo. So now I'm going to the live demonstration of the SETFOS software in Perovskite solar cell. SETFOS are regularly updated, so at here, new trapping models are introduced as the feature highlight of the SETFOS 5.5 version. So SETFOS also supports bulk trap states, energy distributed traps, new model of amphoteric trap states, so such as a dangling bond in amorphous silicon. Number of features of SETFOS are given at here. So it is a SETFOS GUI, Geographical User Interface. So I explain each of the tools that given a website. It is a for create new simulation file. If you click at, you can create your own Perovskite player cell. It is existing example at given. You want, if save your simulation, you can save at here. Number of existing results are also present. It is a passive optics modules. It is a absorption modules. It is a drift diffusion modules where you can calculate all of the electrical parameter. In absorption, you can absorption of the activate when the modules multi-layer optics. You can calculate at the light incoherence and support layer specific absorptions. It is a light. It is a emission modules, bulb-like symbols. It is a scattering modules. It is a master equation mode where you can excitant parameter you can calculate it at the drift diffusion and light emissions can couple. If you shift number of the parameter, you can shift at here. It is a optimization. If you want optimize your better accuracy, if you want, and you parameter want to extract, you can do it here. If you want fit the emission parameters, so you can emit that parameter. It is a graphical input. It is a script mode. Graphical input where you provide all of the input and script which data you are given. It can be a so you can edit at here if you want. It is a console outputs when you run the simulation, and it is a result view when you run the simulation, and result can shown at here. When you activate that modules, you can see at here drift diffusion settings will be on, and when you absorption modules activate, the absorption settings are on. It is a layer structures. It is an example which we are given. It is a path. In SETFOS, you can create your own data. So now I'm going to create perovskite solar cell. So firstly, I want to add number of layer. So at the plus I symbols, you can add number of layer. There is no limitation of the layer. You can add. air, it is incoherent, aluminum. Don't mention at here special characters, one otherwise it will be show at invalid layer name. One by one, you can mention each of the layer. It can be your project basis, your layer. If that layer you want, you can put at here. Generally, I consider one of the examples, so I put my own data for your understanding. Now we will be mention thickness at here. That thickness I'm given 50 mm. 300 mm. FTO 400 mm. At the top and bottom, our thickness I'm considered 0 because it is a semi-infinite medium and it is incoherent, so thickness are irrelevant at here. You can see at here layer structures. It can be changed as per mention of the thickness. Now I will be imports refractive index. Those medium which show dispersion medium and wavelength dependent, we will be mentioned at here refractive index. File always supported NK format, so we will be import that here. Spyro. Import perovskites. I'm considering at here CS3NH3, PBI3. As perovskite formula, as we know, ABS3 that follow. So imported. Similarly, we import each of the layer. FTO. As I imported FTO, aluminum, all the refractive index files. So I'm making at the perovskite solar cell. So we need to mention electrode. So we activated drift vision modules for the electrical parameters. And at the general settings, we activated electrode and mention at the boundary condition and work function. It can be aluminum work function, and if you want another, you can choose. As we know, in between semiconducting materials always exist between the electrode. So we activated semiconducting layer and imports. If you want semiconducting materials, imports the file, so you can directly import it. But now I have mentioned each of the data. The HOMO energy level effective density unit will be considered centimeter per cube. Dielectric strength it is a whole transport layer as the sector droppings I'm considering. Optical generation efficiency at mentioned at 0 because it means that how much layer that absorb. Exciton are not mentioning it here. If we are mentioning it here tab, it is a limitation of the electron and hole movements. So now I'm mentioning it here trap density. It will be a below HOMO. Electron and hole capture rate need to be a mentioned constant. Electron and hole capture rate means how the efficient nucleus attract the electron. It will be considered same for each. Similarly, for mentioning recombination efficiency, I'm considering 0 at here. It is opposite of the carrier efficiency. Similarly, we mentioned at the perovskite semiconducting properties. As I'm considering Sparrow, I'm considering it here. It will be the same. It is a donor topping. We are calculated at here perovskite materials, optical generation efficiency considering 1, and mobility, electron and hole mobility taken unit considering centimeter square per volt second. Exciton does not mention it here. Trap density at here mentioned 2.2. Electron and capture rate and hole capture rate will be considering constants as I have previous. As I have told for the ions, you can see it here, mobility, anion for cation, you can mention recombination efficiency considering 1. Unit will be considering centimeter per cube. Dielectric distance considering trend. Doping at here, donor doping. We will mention it here. It also will be 0 as same spiro, only except for perovskites. Exciton does not mention here, but we enable trapping for these materials. Plus, we can add trap density. Trap energy. Below him it will be same. Electron and capture rates. Considering constant. Mobile ions. Recombination considering at 0. Type of recombinations also given at here. Language auger bimolecular simplified SRH. That's you want, you can do. Now, as you can see at here, mentioning minus electron layer is not defined. So we need to complete their structures. FTO considering at electrode, so status will be okay. So SETFOS also give the instruction about your layer. Now you can activate absorption settings. You can see it here 380 to 780. It means wavelength that vary at here. So you can also change at here value. Illumination spectrum files, you can see at here. Same. If you want to change, you can change at here. But I'm considering at same. Intensity scaling, it is for your pixels. For the diffuse amount of diffuse light, you can also diffuse parts can be calculated. Wavelength 550 nm and incident angle 0. As per unit, you can change. Now we will be set at the drift diffusion settings. Voltage as considering 10 volts. If you want to temperature, you can also change. At the bottom, electrode calculations and another calculation you can also do. You can enable that parameters because you have need to calculate trapping and exciton output settings. Now you can shift your parameters, which parameters according you want. So optical, electrical, layer, electrodes, top and bottoms were fine. Which type of parameter you can vary it at here. As voltage I'm considering, and you can also give the value from minus 0.1 to 1.2. As step is considering 0.05. Now you can see at here layer structures are completed. So if you want more parameters want to give, you can give. And now you will be give the name at here. And you can run your simulation. Now you can see at here results, built-in voltage, current voltage, device currents, power conversion efficiency, power density. All of the electrical profiles are also given at here. Charge generations, electrical field, mobility, potentials, recombination, trap capture rates. Solar integrated absorption. Passive optics modules are also activated, so you can calculate all of the characteristics. Reflectance, extract contributions, transmittance. You can see at here your results, built-in voltage, short circuit currents, recombinations, perovskites, relative current continuity, optical key figure. So different results are also shown at here. Cyclic usual efficiency, it is come across at the optical band gaps. If you want to mention band gap, you can also mention at here. It is given at here optical band gap tab. If you want to change that value, you can change according to you. Perovskite solar cells had number of examples at given at here as like perovskite transients, perovskite voltage and current, and the hysteresis. As the transients examples are also given at here. Device current components, device current transient, device currents voltage, device voltage transient. You can change also at here the tab look like you can move at here. If you want to change x-axis, y-axis, range, shift, you can change. At the time steps, photocurrent, you can see at here. It is a photocurrents. Number of the examples are given. So for the white emissions, as I have already performed, emitted optimizations. So now at the new simulations that I want to do for the OLED. So now I'm going to for the OLED structure, and I will show the optimization and fitting parameters, how we can optimize our results. Air, calcium, polymer, nickel, aluminum. You need to mention their thickness. As I've already told, top and bottom are semi-infinite mediums and incoherent. So thickness are irrelevant. We need to import their file. As I've told which medium show dispersion, so we can select at here refractive index file, which is wavelength dependent as you want to calculate. Similarly, you imported aluminum. For the calcium, you can mention at here refractive index. One of the important things that I can tell you, if you want create your refractive index of the materials and your own data, you can create at the notepad tab. At your goal to make process more efficient and logical, for the optimization parameters we can use at here emitter parameter photoluminescence spectrum dot file. It is support .pl file formats. So we will be imported at here. You can need at mentions exponential, Gaussian, exciton coupled, absorption coupled, recombination coupled. You can mention at per your choice. Now you can give the name. So you can see at here given results as I have given. It is for the OLED emitted color diagrams and exciton density, radiating dipole densities for the polymers. It is given at here. Now, if you want to optimize the thickness, now I will show how to optimize the emission layer thickness of the simple OLED structure in order to maximize the radiance. Dipole radiance, it is a form of electromagnetic radiation emitted by a change in electrical dipole moment. When we activated the optimization modules, I will give the parameters, and as we want optimize the thickness of the polymer, so I considering at here. It can be initial and pre-scan minimum to max value, you can choose that you want. You need to mention at here target. As we are maximize the target, so how will be the thickness we can get? You can give at here. It is a radiance file. So if you want to maximize that file, so target at set at here. Now if you want to run that simulation, optimization at accurate here, you can see at here polymer thickness 250. If you want the minimum, you can see at here 10 nm. You can change at here global plus local search for the better and possible results. You can also change according to radians. Now you can see at here 249. So now we can also fit the emission parameters as go through the results. If you want to fit the emission parameters, you can click at the right sides and select the data, save visual data. You can create their file spectrum. You can save it here. Now if you want to fit that parameters, quenching will be disabled at here. You will be activated the fit emission settings and import their file. At here your file are present which imported. And run the simulation. You can show at here results the fit emissions. It is the resulting emission spectrum for the emission plot. At the next list these spectral data for the fitting target to reconstruct the dipole distributions. Firstly, here we calculated artificial emission spectrum and then SETFOS reconstruct the dipole distributions. So you can fit your own data, got your better accurate result. So you can see various examples given at here. As I'm showing at here, fitting optimizations data, number of the fitted dipole distributions, fitted recombinations, color diagrams, optical profiles, refractive index. As you can see at here, number of examples are given for the OLED. It is the master equations for the excitant parameters, full OLED for the saturations, perovskites, current and voltage curves. If you activated the drift vision modules, you can also see it here, auto Newton, Gauss solver, and current continuity, relative change, absolute current change, and damping. Also, you can done. And for the transient data, you can select at here transients, number of the transient signals. If you enable, you can create the graph for the hysteresis curve, RAM, sine, file, and you can set at here level voltage, currents, number of the repetition points. For the temperatures, they also you can enable transient temperatures here. And the transient solver, you can give the numerical tolerance value at most close your answer. Spot transients, spot transient profiles. For the signal frequency analysis, spectral analysis, you can also done. In the mass scattering types, also given at here, for the H spectra and number of the angles, you can given at here as per your calculation, as per your results, master and equations parameter if you enable. So you can also intermolecular spacings, photon radius, distal radius, singlet and triplet models, you can also give it. SETFOS also help at the number of the models at the manual and tutorials are given at here. So it is too much easy tool for us. You can simply go with the tutorials and search your query. At here, if you want to calculate any parameter voltage, you can give at here and you can search at here voltage related current voltage curve as the page number given at here. You can simply search all the query. You can simply search your own self. Dipole distribution, my first emission zone fittings. So at here tutorials are given.
So screen is not visible, sir.
Sorry for the interruptions. It will be disconnected through the network issue. Tandem OLED and tandem OPV each optimization, tandem perovskite solar cells also given at here. I have performed number of the tutorials. So discard that here. Light device simulations at LED for the polymers. For the solar cell at the PEDOT, aluminum P3HT, PCBMs, number of the absorption settings are given at here. Max side traces, damping, you can check out here. You can ship your parameters. Number of the parameters given at here, accident angle, wavelength, intensity scaling, cloud over, normalized, effective reflect index, energy, current density for the emissions. Mode analysis, also it is a polymers for the dipole position. The thickness that will be vary according to the dipoles. You can also ship at here.
So what is the minimum configuration to download this software?
Sir, it is need a 64-bit kernel in 64-bit. macOS allows you can go macOS. You can use it here. Linux you can also use it here. Windows 11, 10.
What about RAM and processor size, sir? Means i5 or i3 like.
Yes, it will be used for the i5, i7s. You can easily use it here. Okay, I got your point. Impedance graph also given at here. Impedance dopings. Interface, you can also create that interface through that layer. If you want to calculate interface for the scattering models, you can give the interface characteristics as hoppings, interface traps, and that's excitant dissociation for the interface. You can give that inputs at here. So it will be very easy because examples are already given at here. But if you want to create your own data, you can see at here the examples and you can work according to this. So you make easy access that tool. Master equations, emissions, and OLED dots. So saturations like that. So if you have any query, you can ask. About the SETFOS software. So please, if you have any query, please ask.
So, dear participants, we would like to tell you, our speaker has explained about some things related to solar cells and LED applications. Now, if you would like to explore, there are many couple of things are given in the example as well as tutorials. So in terms of, if we talk about the advantage as compared to the other existing software available, like here, this is one of the example where there are multiple interfaces are taken in between the electron transport layer and perovskite layer, as well as the whole transport layer and perovskite layers. So in this particular example, if you would see in this right side, the layer structure, the visualizer is also there where you can visualize your device structure, as well as the energy levels. The energy levels which is given the HOMO-LUMO value which is displayed here. And this interest, let me simulate this particular device where if you will see the sweeping is done with multiple parameters at a time. So in this particular structure which you are visualizing here right now, there is sweeping functionality are enabled. And here you can optimize the multiple parameters. You can see the voltage are sweeping from 0 to 1.1 with the interval of 0.02. So this is one of the parameter, voltage is sweeping. Parallelly, the trap density for N-type for top interface. For C60 top interface, the trap density are sweeping with 10 to the power 20, 12 to 4.1 and 10 to the power 13 with the step size of this particular per meter cube. Similarly here, if you see, look into that, 5 parameter at a time sweeping. So it will be better to optimize your parameters to achieve your highest efficiency. So multiple parameters are sweeping here, and if I try to run by clicking on this button, it will simulate your device structure on 5 parameter sweeping from minimum value of that particular parameter to maximum value, whatever the value is mentioned from to 2 with number of intervals. So based on that, you can judge that at what value your device will be more accurate. So the structure is simulated. If you see here, the calculation is finished 100%. And in the output window, this is the output window where you can see your IV characteristics. Now this IV characteristics, the results are varying. The results are changing with respect to the concentration, with respect to the other parameters. So here the 5 parameter, whatever we enabled in the sweeping functions, accordingly it are displaying here. And if we increase the concentration, how the current will affect the concentration of your IV characteristics. So what will be the impact of your concentration on your IV characteristics that are displaying? So this is basically a C60 interface for trap density, where the concentration are affecting your device characteristics, IV characteristics. Similarly, if you want to vary other parameter, top interface, bottom interface, C60 interface or TATM, that is one is whole transport layer and another is electron transport layer. So whatever the layer doping concentration will impact your output, that you can also visualize with single click. If you want to export your data, you can simply right click. You can export your raw data in form of image. So once you will right click, you can visualize this image option. Click on save image, where you can save your data in the form of PNG, in the form of JPG format, in the form of PDF format and SVG format. So these are the 4 format, image format, where you can export your data with the to visualize the more pixel ratio. So if you will click on it, you can save the path where you want to save your data in the form of image. Let's suppose IV is the file name that I mentioned on my desktop, and click on save button. It will save your data in my desktop with this image format. Similarly, if you want to save this data instead of image format, you want to get in the text format. So text is a common format where you can get your data in visual format. The text format or Excel is also possible, where you can mention the XLS formats. So I can mention here the IV dot text is by default, but if you want to take in dot XLS, you can mention dot XLS. It can save in this XLS format as well. So dependent on your particular format, you can export your data. If I want to show you, this is the output format, which is saved on my desktop folder. So it is opening, and let it wait. and behind that there is image format graph is also there. So easily the data can be extracted. Even you can also want to import your other data, it can also get it import. And let it open. In the meantime, if you would like to see the, if you want to see the data in text format, same data, so I can click on right click, save in this visible data. And on the desktop, I am saving for my convenient. And this is iv.text file. So I click on save. And this is one of the, 1 minute. One minute. So there is some system network issue. So just a minute. So this data is also present iv.text on my desktop. So let me see where it is. This one. So this is the text format. The data is also visible. So you can copy paste in the origin or any other Excel or any format. The data can be exported. So this is one of the another device structure where multiple 5 parameter at a time it is sweeping and optimizing. Similarly, these are the multiple traps that are enabled. The trap with their concentration, their trap density parameter, trap because we have to capture the electron and holes. That's why the trap density, trap energy levels, electron and holes capture rates are mentioned at the interface in between two materials. Similarly, if you look into the multiple other application, I can ensure you the software is very broad where you can find. This is one of the complex structure where multiple terminals are there, 2 cells are there. So if you see, this is one of the C60 perovskite nickel oxide interface, middle ITO, and different amorphous silicon N-type intrinsic buffer layer, and then bottom hole transport layer ITO. So around 10 or 12 layers are there. So more than 10, 12, even 20 layers for multi-junction solar cells. You can also get it simulate. And here the voltage are sweeping with different steps. So 0 volt to 2 volt with a particular interval. Instead of linearly the voltage buying, here we are defining a particular points, particular value that we want to run the calculation instead of linearly increasing the bias voltage. So if I simulate this tandem perovskite silicon electrical characteristics, so let it simulate, and it may take 2 minutes hardly or 4 minutes. Then you can visualize around 20 layers. You can see here the number of layers are 19 in this particular devices. So even beyond that, if you want to go, there is full possibility to do that. So not only this, there are a couple of other advantages also there, like impedance characteristics, where the real imaginary part of impedance analysis, Nyquist plot, capacitance, conductance, susceptance. So all basically optoelectronics domain, the software will be very quick, useful, and user friendly. Here you have no need to write any script or code, which will take a lot of your time in writing and finding the errors. So just a bit, it is executed.
Sorry to interrupt you, sir.
Yeah,
Can you
please.
please tell me if we can implement our raw data to that software? And sorry for the background noise. Actually, I'm out of the office. Sorry for the background noise. I just wanted to know that can we implement our raw data that we have into this software?
Yeah, definitely. There is also provision to import your data. So let it finish this calculation. Then I will try to show you how you can import your raw data into the software, and then you can compare it.
That would be great. Thank you so much, sir.
Yeah. Just a minute. So around 70% calculation for this particular structure is done. So within 1 minute, it will be finished. Now the simulation is done and you can see the multiple device characteristics. So this is IV characteristics with different recombination parameter. So this is for recombination and other are there like this blue one. This is basically for Langevin recombination. This pink one is for biomolecular recombination and another some of them are behind that graph. So we can visualize like that. And sir, as you were asking how to import your data. So you see there is an option called import button. If you click on import, you can import your IV data here. You can import your IV data and you can also compare it. So you can give the name my import. Let's suppose burn my import. If it is combined with that, then it will display here. Like there is some difference in the X and Y axis. That's why otherwise you can visualize all your data on single place and compare it. So this data can be imported here if the voltage range are same, whatever you have importing, and the current can be different, but the voltage range should be same so that you can import and compare it. So this provision is there where you can import your data and you can also compare it. Secondly, if there is impact of recombination SRH current or other parameter, so you can find this IV characteristics related to that. Similarly, the power conversion efficiency, where we are achieving around 28% for 10 perovskite silicon solar cell in this particular device. So it can also display here the key figures. So this is like VOC value, the GSC value, fill factor value, maximum power density, and the power conversion efficiency. You can multiply it by 100 and you will get a 20% efficiency for this particular example, which I show you for 10 perovskite applications. So even beyond that, there are a couple of many things are there which could not be explored in 1 or 1.5 hours. But I can assure you the software is very broad. So even some AC analysis also. So this is one of the example where simple gold metallic electrode, calcium on the back electrode, and organic molecule is there. This particular structure, right side visualized and energy levels. Here we will try to see the impedance related characteristics. So if I will run it, simulation is finished and you can see the impedance. So this is the Nyquist plot, the real part. This is called the real part of impedance and bottom one is called the imaginary part with respect to frequency. So from that we can export your data and we can plot the graph in between real and imaginary part also for the Nyquist analysis. So this other characteristics, capacitance you can plot, conductance you can plot, capacitance, conductance, Mott-Schottky analysis is there and susceptance is there. So many other electrical impedance characteristics is there. Electrical impedance profile is also there. So this is in the form of AC charge density profile. Real part you can visualize in the graphical representation of density. And similarly, the imaginary part of AC charge density. So these all analysis, whatever I'm clicking here, you can visualize in the respective format. So I believe the software will be very quite useful for your particular applications. And let it explore more information. And if you want to see the on our website also, many blogs is also there. So you can read the blogs, you can read the YouTube channel of Fluxim, where you can see a couple of video related to equipment as well as the solar cells and LED applications. So even if you will click on Fluxim, this is one of their channel, our OEM channel on solar cell and LED research videos. So either you are working on stability related product, or you are working on simulation related product, or some electrical optical characterizations. So all the analysis in past, they also conducted many webinar series. So they have a huge list of webinar available on their channels. So, and even they discuss in details. I have given you the brief discussion about their product, but if you want to know the back insight, so you can join these multiple sessions which they conducted. Even if you want to attend their session directly, they also attend such kind of webinars. So you can register yourself in their upcoming webinars. So you can see here the research webinar coming on 17th December. This will be conducted by Fluxim directly, our OEM partners. So if you want to attend this webinar on from precision to skill thermal evaporation, transforming perovskite device design, and many more will come in the future. So you can register yourself. There is registration link is there, so you can register, and you will get the notification to attend the future webinar that will be conducted by our partners. So I think this is the information that I wanted to show you. So you can find this in link here. You can click on this fluxim.com and click on this. Go down and event. This event section is there. Once you click on event section, there is registration link is there. You can register and you can find more insightful information. Even past information is uploaded on their channel, and upcoming information you can find on the website. So from our side, thank you for all the time given your audience this 4 days time. Tomorrow session will be specifically on experimental part and as well as some simulation part for nanoelectronics. So probe station, sample characterization, and some chiller, butter chiller, and some sample holders. So different kind of thin film and solar cell experimental characterization setup that will be shown to you, and as well as some nanodecal plus and rescue plus for advanced version that will also be discussed by our one of expert from Canada, Nano Academic Technology. She will deliver one of the talk on advanced nanoelectronics related applications. So from our side, thank you very much for joining your session. If you want to register on Fluxim event, you can find the link on the chat box and you can register yourself. So if you have any questions, please unmute your mic and you can ask your questions directly. Thank you. Thank you for your time once again.
Sir, what is the cost for this software for user per user?
Yeah, as I told you yesterday also, the cost is dependent on the module, like which module you are interested. So SETFOS module and number of years of validity. So for 1 year, you can assume for 2 modules, 3 lakh plus GST in Indian rupees. So based on module, it differs.
So that payment,
Sir,
that payment we have to give at once only, or installation is possible?
Sorry, what did you say? Can you please repeat?
Installation is possible, or we have to give once at time?
Installation is possible?
Means installment, we can give in installment?
No. There is a, like 1 year validity, 3 year validity, 5 year validity. So if you want to go for 1 year, you have to pay for 1 year. If you want to go for 3 years, then you have to pay for 3 years. Or there is provision, let's suppose you buy 1 year license. If you want to convert into the 3 year, so by paying the remaining amount, you can also convert into the 3 years. Any other participant have any other query, please unmute your mic. And tomorrow we will discuss about the experimental characterization as well as the plus version of nanodecal and rescue.
Hello.
Yes, please.
Sahil. Tomorrow, please provide the Google Meet code also, because some mobiles is not being taken to link that connection from the link you are given. So it is saying that it has to update, but it is not connecting that. So it is asking the code of the meeting also.
Okay, understood. We will provide you the code.
Yeah,
Even
because we'll be moving the out of colleges, it will be difficult to handle the laptop.
okay, okay. Definitely, we will share you. Okay, thank you.
Thank you.
Any other participant have any more queries?
Hello, sir.
Hello.
Sir, how we upload the postcard file in the Rescue software?
So you can share your postcard file, and we will upload and share you the screenshot and a small video we will prepare and share it to you.
Okay, sir. I send you an email.
Yeah.
Okay, sir. Okay, sir. Thank you.
Any other participant have any query? So I think there is no more query. So the time is also have finished. So thank you very much for giving your time. And please join tomorrow at same 5 p.m. and try to attend the.
Sir.
Yeah, yeah, please.
Hello, sir.
Yeah, please.
Sir, I cannot attend. I cannot join your WhatsApp group.
There is some WhatsApp privacy is there, so I will check it. Some people are not able to join it, so I will check it and update you.
Thank you, sir. Thank you.
Yeah, thank you. So thank you to all the participants. Now I'm disconnecting the call. Please come tomorrow at same time. Thank you.
Thank you, sir.
Yeah.